Hey guys, Jake here coming at you with another math lesson today. Doing it live again. Got our weekly live stream tonight. Today we're going to be going over some chain rule examples. I'm going to be showing you the easy way that you can use to not only remember but also apply chain rule super easily to any chain rule example in order to find the derivative of a function. So this is one of the topics actually covered both on my free Calculus 1 study guide and also in my complete Calculus 1 package. If you want to check those things out, there are links to both of those down in the description. So you can, use those. Like I said, the Calculus 1 study guide is free. It's available for instant download. So if you go click that link down there, you can get that pulled up while we're working through these examples. So you have that in front of you. Should help make your life a little bit easier, especially as you work through calculus. But it's going to be going over a couple different examples. Before we go ahead and jump into the examples, I do just want to talk a little bit about chain rule in general. So like I mentioned, chain rule is one of those formulas on my Calculus 1 study guide. In this video, though, I kind of just want to show you the method I use to remember it in a way that actually makes sense rather than talking about a formula. So just to kind of briefly discuss the formula real quick, basically, if you're trying to find the derivative of some function that is a composite function, which basically means you have one function plugged into another function, and you're trying to find the derivative of this, basically you just have to do derivative of the outside, leave the inside alone, and then multiply that by the derivative of the inside. So that's essentially what the formula is, just this right here. But like I said, I really want to kind of take this approach from more of, thinking about what this formula actually means rather than spending too much time talking about the formula itself. So I just kind of talked through that as I wrote out the formula. The way that I like to think about chain rule and remember it, because I think that makes way more sense than just memorizing a formula. So let me go ahead and say that again. Chain rule says that if you're trying to take the derivative of one function plugged into another function, in this case, it's written as f of g of x. Basically, that just means our function g is like plugged into our function f. If you're trying to take the derivative of this, you just have to do derivative of the outside function. So that's what this f prime is. Leave the inside function alone. So you're going to leave whatever this inside function is as it is, just plugged into now the derivative of your outside function. And then you multiply that whole thing by the derivative of your inside function. So let's go ahead and take this example here, and we'll think about how to basically just find the derivative of this function, 10 to the 1 minus x squared, using chain rule. And again, I'm not going to talk too much about the formula itself. Let's really think about kind of the English way that I just said that and broke that down. So first thing you want to do when you're taking the derivative of a function using the chain rule is figure out what is your inside function and what is your outside function. Okay, so the easiest way to start with that is to first think about what is your inside function. Well, your inside function is usually going to be something that is like within parentheses, within a power. There are other examples. Sometimes it may be like within the numerator or denominator of a fraction. It could be a lot of different things. But usually, it's best to kind of think about it by looking first at where your variable appears. So in this case, we can see that our function is a function of x, right? We have an x right here. First, look to your variable. And what you would want to think about is if we were to actually like plug in some value in for x here, if we just kind of work our way out in terms of order of operations, what would be the order of operations that we would apply if we plugged in some x value? Let's say we plug in x equals 5. How would we actually figure out what this whole thing equals? We would plug in 5 here. So we would do 5 squared, first of all. And then we would do 1 minus whatever 5 squared is, which would be 25. And then we would apply the fact that it's 10 raised up to that power. So basically we would first square it. Let's kind of just draw circles around basically each step of the way here. First we would square it. So that's our first step. Then working our way out a little bit further, we would then do 1 minus that thing, okay? And then working our way out a little bit further, we would then do 10 raised up to that power, okay? Now, obviously in this case, we have basically 3 kind of steps of this order of operations that we would be applying if we actually plugged in a number there. However, what we can do is we can just treat basically what we have in this second circle here, this green circle, as our inside function. So let's not worry about the part that has the x squared. Let's just think about the whole power. If we treat this whole power as our inside function, then, like I said, we could just treat the rest, or basically the fact that we have 10 raised up to that power, as our outside function. So let's go ahead and think about how that would apply to the chain rule. So like I said, chain rule just says we're going to take the derivative of the outside function. So once you have figured out what your inside function is, so in this case, we're going to say that our inside function is the power, the entire power, 1 minus x squared. To figure out your outside function, all you have to do is replace your entire inside function by just your variable. So we're going to replace this entire 1 minus x squared by x. And whatever you're left with, that is what you want to think of as your outside function. Okay, so once we've replaced our 1 minus x squared with x, we are just left with 10 to the x power. 10 to the x is going to be our outside function. 1 minus x squared is going to be the inside function. So like I said, a common example of figuring out your inside function is whatever's within a power is a pretty common example. And we knew that in this case, we wanted to treat the power as our inside function because that's where our variable x is. So if we're working order of operations wise, that's going to be the first thing that we're going to deal with is that power. So that power is going to be kind of the inside thing that we want to kind of pull out of this composite function in order to apply the chain rule. So back to chain rule. Chain rule says we're going to take the derivative of our outside function, so the derivative of 10 to the x. So first thing we need to figure out is what's the derivative of 10 to the x? Well, 10 to the x is, just a version of basically a very specific type of derivative, where if we have the derivative of some constant raised up to our x power, this is just going to be the natural log of that base, that constant base, times that base to the x power. So basically, it's this same thing, a to the x, and then we just multiply it by natural log of a. So this is another formula actually on my free Calculus 1 study guide. Again, if you want to check that out, the link is down in the description. But what this formula tells us is the derivative of 10 to the x is going to be natural log of 10 times 10 to the x. Just using this formula here. Okay, so in terms of the chain rule, what we have to do is take, again, the derivative of the outside function, leave the inside function alone. So our inside function still needs to be plugged into the derivative of our outside function. So if our outside function is 10 to the x, the derivative of our outside function is going to be ln of 10 times 10 to the x. However, it's not just going to be 10 to the x, because what we need to do here is we need to leave our inside function alone. We need to leave our inside function still plugged in for x. So we're going to leave this 1 minus x squared as our inside function plugged in for x. So we're actually going to have derivative of the outside function, leave the inside function alone, is going to leave us with ln of 10 times 10 to the 1 minus x squared. And then, like I said before, we multiply that whole thing by the derivative of our inside function. Well, the derivative of our inside function, the derivative of 1 minus x squared, can be found just using the power rule. So the derivative of a constant 1 is 0. The derivative of negative x squared is going to be negative 2x. We would just bring the 2 down in front, multiply it by the minus sign, so -2, and then subtract 1 from the power. 2 minus 1 is just 1, which just leaves us with -2 times x. Okay, so another common mistake, and I'm sorry, I just realized I'm blocking part of that. There we go. So another common mistake here when you're applying this chain rule here, I said it when I was saying the formula, is you need to make sure to put parentheses around this whole piece here and this whole piece here, right? We take the derivative of the outside function, leave the inside function alone, and then multiply that whole thing in parentheses. Make sure to always put parentheses around that, times the derivative of your inside function, which also needs to be all in parentheses. So that's a very common mistake that I see. And I would definitely just recommend making sure that you think of those two pieces as two entire pieces that need to be multiplied together. So that if there is distributing to be done, you make sure to do that distribution there. So this is going to be the derivative of our original function. So this is going to be y prime is all this. Okay. I'm not seeing any questions in the chat there. As always, if you do have any questions along the way, feel free to drop them in the comments. Happy to help address whatever questions anybody has along the way. Even if it's not necessarily on topic of the question I'm doing at the time, feel free to throw whatever questions you have in the live chat here. But now that we've kind of taken a really deep dive into the chain rule formula and how to remember it, that trick that I always like to use to remember the chain rule formula, I'm going to go through these next two examples a little bit quicker. We're still definitely going to reference it, but I'm not going to talk about the actual formula itself as much. So what we will want to do is go ahead and, again, start by thinking about if we're going to find the derivative of this function, 4x minus x squared, all in parentheses, raised up to the 100th power. If we're going to find the derivative of this using the chain rule, what we want to do is think about our inside function and our outside function. So again, inside function, usually you can figure that out by starting by looking at where is your variable, where is your x in this case. Well, we have an x right here and we have an x right here. Basically, in this case, if we were to plug some number in for x and then actually try and figure out what this whole thing would be equal to based on that x value, everything within the parentheses is where all of our x's are. Everything within the parentheses would be the first part we would deal with. So basically, we can treat what's all in the parentheses here as our inside function. And then we can treat essentially everything outside the parentheses, which is just this 100th, power part, as our outside function. So let me actually go do it like this. That'll be our outside function. Okay. So like I've been saying, basically, the chain rule just says that in order to find the derivative of an inside function plugged into an outside function, like we have here, we're going to take the derivative of the outside function. So we're going to deal with this 100th power first. So what you would want to think about, again, to think about your inside function, that's already figured out, right? That's just what's in the parentheses here. Then to actually figure out what is the function that we actually want to treat as our outside function, it's not just 100, right? We can't just say 100 is our outside function. What we need to do is look at the entire outside and inside function combined, replace just our inside function with your variable, with x. So if we replace everything inside the parentheses here with x, we would be left with x to the 100th power. So x to the 100th power is actually what we want to think of as our outside function. Okay, so if we're going to take the derivative of the outside function, that's just going to be power rule. We can just bring the 100 down in front and then minus 1 from the power. So that would give us 100 times x to the 99th power. Okay, that's kind of sloppy. Let me rewrite that. However, since we want to take the derivative of the outside function and leave the inside function alone, we now need to go back here and replace our x with our inside function. So let's go ahead and do that. So instead of writing 100x to the 99th power, we have to write 100 4x minus x squared to the 99th power. So we've taken the derivative of our outside function. We've dealt with that 100th power part, taken the derivative there, left our inside function alone. We've left our inside function as minus 4x, or I'm sorry. We've left our inside function as 4x minus x squared. And then we need to multiply this whole thing by the derivative of our inside function. So the derivative of 4x minus x squared is just going to be power rule again. Derivative of 4x is 4 minus 2x. Derivative of x squared is 2x minus minus. So now this is going to be the derivative of that original function there. We could do a little bit of distributing if we wanted to, but I don't think it's really necessary. It's not going to give us a function that's any neater or easier to deal with, so I don't think there's really a point in doing that. All right, not seeing any questions in the chat still, so we'll go ahead and continue on to the next example here. All right. So again, we're going to go ahead and use the chain rule to find the derivative of this function y equals sine of x. So this is a pretty interesting example. It's still going to be able to be found using the chain rule because we have a composite function. But this is a very interesting one because we have more than just a single inside function and a single outside function. We actually have three functions now plugged into each other, basically like three levels of composite functions, basically. So this is a pretty interesting example. And I have made another video about kind of the same idea of how to do chain rule when it's more than just one inside function and one outside function. But I'll kind of talk about that a little bit more here. In terms of our approach that we've been taking here, where we're just thinking about kind of this one easy method to remember, the chain rule formula of just saying, derivative of the outside function, leave the inside function alone, times the derivative of the inside function. Well, again, what we want to do is kind of think about the inside-most function and work our way out. And we'll kind of think about it, step by step. So again, my main trick for doing that is start with where your variable is. Start with where x is. In this case, we only have an x right here. We don't want to just ever say our inside function is x. That doesn't really help us. We need it to include more than just x. So what we can do is if we, think about our order of operations, if we were to plug some number in for x here, we would first deal with sine of that number. We would deal with this first sign here. So basically this innermost parentheses would be the first thing we'd deal with. So let's go ahead and call that our first level of inside function. Okay. Next, once we figured out what that first sign of x is, what would we deal with next? Well, we would just work our way out one level outside of the next set of parentheses, and we would do sine of that thing. So then we would deal with this second sign, basically. So we'll go ahead and say that this is now our second most inner level. Okay. Then, once we figured out what sine of x was, we would work our way out one more set of parentheses. So then we would deal with this sign out here. So this would be like our, third most inner function, or in this case, our outermost function. So we have these three levels, the innermost, the middle, and then the outermost function. So we're still going to use the same kind of method that I've been describing, except instead of thinking of it as just derivative of outside function, leave the inside alone, times the derivative of the inside, we'll kind of think of it as outermost and then the next level to the inside. So what I mean by that is, first, we're going to go ahead and think of finding the derivative of our outside function, our outermost function, I should say, our third level function. So in this case, it's sine of all this stuff. But we're going to use that same trick where whatever the next level of inner function is, so in this case, our 2 circle, our orange circle of number 2, we're going to replace all of that with x. So basically, if we think of our outermost function in this case, it's going to be sine of x, because if we replace the next level of inner function with just x, we just get sine of x. Okay? Same kind of idea if we think about what is our outer function, if we just look at this kind of centralized, just these first two layers, right? If we replace our innermost function with just x, which is this first sine of x here, we're just left with sine of x, right? If we replace this whole green circle with x, the orange function becomes sine of x, okay? And then our innermost function, that's the easiest one. Our innermost function is just everything within this innermost green circle here, which is also sine of x. So basically, our inner function is sine of x, our middle function is sine of x, and our outermost function is sine of x. So how does chain rule tell us to deal with this? Well, chain rule says that we're going to take the derivative of our outermost function, so the derivative of sine. The derivative of sine is going to be cosine. Okay, we're going to take the derivative of our outer function, leave our inner function alone. So we're going to leave our second layer of function and everything within it. So when I'm talking about our middle function here, that kind of includes this first level function within that already. So we're going to leave our inside function alone. Well, our inside function in this case is sine of x. So we're going to leave this inner function sine of x alone, okay? Then we multiply that by the derivative of sine of x. So basically we would then multiply that by the derivative of sine of x. Okay. But now look at when we have here the derivative of sine of x. Now this derivative, just this one little chunk of our problem right here, is going to require the use of the chain rule, because now we have an inside function and an outside function. Okay, so now just to find this derivative piece here, we need to again apply chain rule. So we'll go ahead and leave all this over here. So we're going to leave cosine of sine of x. That's just going to be left alone out there. Now we're going to have to apply chain rule basically a second time to find the derivative of sine of x. So again, chain rule says we're going to take the derivative of the outside. The derivative of our outside function is the derivative of sine of x is cosine of x. So we're going to take the derivative of the outside function, which is cosine, leave the inside function alone. So we're going to leave this inside sine of x as sine of x. And then we're going to multiply that by, the derivative of the inside function. Well, again, the derivative of our inside function, which is sine of x, is cosine of x. So now we get this whole thing times this whole thing. So now our derivative of our original function is going to be kind of these three separate pieces, which we get from each layer of working through the chain rule. So this is the derivative of our outermost function, leave the inner 2 alone, times by the derivative of the inner 2, which the derivative of the inner 2 is the derivative of the middle, leave the innermost alone, and then times by the derivative of the innermost. So you're basically just starting with the outermost function and working your way in one function at a time. And each time basically leaving all the functions that are, more inside of that layer as they are alone, just leaving them alone. So hopefully that kind of clears that up a little bit. But this is going to be now our y prime. So this same method could basically be applied if you had even more layers, right? So this case, we just had 3 layers. Theoretically, we could do this exact same process with like 5 layers, right? Like if we had y equals sine of sine of sine of sine of sine of x. And I know that seems crazy, but it's the exact same idea. You would just start with the outermost function. That would be your outer function. All this would be your inner function. Then when you're taking the multiplying by the derivative of your inside, you would treat just this as your outer function and all this as your inner function. Then when you multiply by the derivative of your inside, you treat just that as your outermost and treat all that as your inner. And then again, so you're just kind of working one layer further and further in. You would end up with these like 5 different things being times by each other by the end of the process. And you would end up with the same kind of thing where it's each piece just getting a little bit more simplified because you're dealing with one fewer sign plugged into that. So I'm not going to go through this example, but I think this would be a fun example if you want to kind of test this out on your own. Go ahead and see if you can find the derivative of this function using the same process that we just went over with this example up here, finding this derivative. All right. Yeah, like I said, chain rule is one of the topics that is covered on my free Calculus 1 study guide, and it's covered in quite a bit more detail as well on my Calculus 1 package. The links to both of those things are down in the description. If you want to go check them out, you can just go ahead and click on those down there, and that'll take you right over to them. They're both available for instant download, instant use, so you can start using them right now if you want to. But that's all I had prepared for you guys today. I'm not seeing any questions in the live chat, so we'll go ahead and wrap things up there, and hope to see you back next week. Thanks, and see you next time.